The ozone layer is healing. In order to understand why this is important, let's recap what we know about ozone. Imagine you have a precious crystal ball, and this ball is what keeps you safe from harmful rays that come from the sun. But one day you notice that your crystal ball is getting thinner and thinner. You realize that if it keeps getting thinner, it won't be able to protect you from the sun's rays anymore. This is what happened to our atmosphere in the 1970s and 80s. Scientists in Antarctica discovered that our protective layer, the ozone layer, was getting thinner every year. And by the mid-1980s, they realized that the ozone layer was in danger of disappearing completely. The ozone layer is like our planet's sunscreen. It protects us from the sun's harmful rays. But there was a chemical called chlorofluorocarbons that we used to use in a lot of things like refrigerators and aerosol sprays. These chemicals were like little holes in our sunscreen, letting in too much of the sun's rays. So people all over the world came together to ban these chemicals and save our ozone layer. Now fast forward to the present day. Because of the hard work and dedication of people worldwide, the ozone layer is slowly but surely starting to recover. In fact, a recent report found that we're on track to have a fully recovered ozone layer within 4 decades. This is all thanks to the international treaty that banned the use of chlorofluorocarbons. Just like how we need to take care of our bodies by using sunscreen, we also need to take care of our planet. And just like how it takes time for a sunburn to heal, it takes time for our ozone layer to heal too. But if we keep doing our part in taking care of our planet, we can ensure that future generations will be able to enjoy the same protection from the sun's harmful rays that we do today. This was only the beginning. A scientist was buried on the moon. There could have been no finer tribute to the legendary planetary geologist Levi Shoemaker, who said his greatest unfulfilled dream was to go to the moon. His ashes were launched aboard the Lunar Perspective probe to the moon, enclosed in a special capsule that is a mere 1 3/4 inches long and 7/10 of an inch in diameter. This capsule was then wrapped in a piece of brass foil on which is inscribed an image of Comet Hale-Bopp, meteor crater in Arizona, and a passage from Shakespeare's Romeo and Juliet. Shoemaker was best known for his expertise on extraterrestrial impacts and his discovery of comets with his wife, Carolyn. He was a distinguished scientist with the U.S. Geological Survey in Flagstaff, Arizona, where he established their astrogeology branch. Tragically, he died in a car accident in Alice Springs, Australia, while conducting field research on impact crater geology. His ashes rest on the moon, the place where he so longed to be, a fitting final resting place for an outstanding scientist and pioneering explorer. The tribute was proposed by planetary scientist Carolyn C. Porco, who was a student of Shoemaker's at Caltech. She designed and crafted the inscriptions on the brass foil, including the passage from Shakespeare's Romeo and Juliet, which speaks of taking someone's great soul and turning it into little stars, so that the face of heaven appears as if made of these stars. This metaphor gave Porco the inspiration to send Shoemaker's ashes to the moon, where he can become a part of the celestial body that he so deeply loved. The scientist had always desired to explore the moon as an Apollo astronaut and study its geology firsthand. Unfortunately, health issues prevented him from doing so. He continued his lunar research by training the Apollo astronauts in lunar geology and impact cratering, and he even provided geologic commentary during their moonwalks. He played a significant role in the pre-Apollo Lunar Ranger and Surveyor programs, and he was the science team leader on the 1994 Clementine mission. And what about you? Would you like to be buried on the moon? Or would you prefer your body to chill on Earth for eternity? One thing is sure, it must feel really lonely to be the only person buried on the moon. Curiosity sang happy birthday to itself. But perhaps what's even sadder is to be alive, wandering alone on the surface of Mars on your own birthday. Unfortunately, this is what the poor Curiosity rover witnesses every year. Curiosity landed on Mars on August 5, 2012. It was born on Mars that day, and so scientists consider that day as its birthday. Curiosity employs an instrument, the Sample Analysis at Mars, SAM, that runs some great science experiments on Mars, analyzing some soil samples. To make the soil samples go down, scientists had to program SAM to vibrate at various frequencies. When they introduce a sample into SAM, it goes through resonance and produces a sound. To commemorate Sam's birthday and Curiosity's birthday on Mars, NASA decided to play a little song. If there was anyone listening on Mars on this special occasion, they would hear a happy birthday song. This is a first for NASA and for the world. Once again, music brought us all together. Oh, I almost forgot. This happened only once. It was in 2013. It might have been the only time someone played music on Mars. The exploration of our solar system has been critical to our understanding of the universe and the planets that orbit around our sun, and Curiosity is just one of the exploration missions we had. Spacecraft from different countries have been launched all over several decades to explore the planets in our solar system. In fact, spacecraft have actually visited every planet. Spacecrafts have visited every planet. One of the most notable spacecraft that has visited planets in the solar system is Voyager 1 and 2. Launched in 1977, the twin probes have reached the furthest areas of our solar system and beyond. Voyager 1 was the first spacecraft to enter interstellar space in 2012, almost 35 years after its launch. Voyager 2, on the other hand, was the only spacecraft to visit all 4 of the outer planets: Jupiter, Saturn, Uranus, and Neptune. Another impressive spacecraft is the Cassini spacecraft, which orbited Saturn from 2004 until 2017, when it was deliberately plunged into the planet's atmosphere to prevent contamination of its moons. Cassini captured stunning images of Saturn's rings and moons during its more than a decade-long mission. The Juno spacecraft was launched in 2011 and arrived in orbit around Jupiter in 2016. Since then, Juno has been investigating Jupiter's atmosphere and magnetic field, providing new insights into the largest planet in our solar system. NASA's New Horizons spacecraft, launched in 2006, also made history when it flew by Pluto in 2015, becoming the first spacecraft to visit the dwarf planet. New Horizons has continued to travel beyond Pluto, exploring the Kuiper Belt, a region that contains icy objects beyond the orbit of Neptune. Several other spacecraft have visited the inner planets of our solar system, such as the Messenger spacecraft, which orbited Mercury from 2011 to 2015, and the Mars Reconnaissance Orbiter, which has been orbiting Mars since 2006, studying the red planet's geology and climate. The exploration of our solar system has been made possible by the hard work and dedication of scientists and engineers. The spacecraft that have visited planets in the solar system has provided valuable information about our neighboring planets, allowing us to learn more about our own planet and our place in the universe. From Voyager 1 and 2 to Cassini, Juno, New Horizons, and beyond, these spacecraft represent some of humanity's greatest achievements. We are basically explorers and pioneers. In less than a century, we managed to visit all the planets in the solar system. However, the same doesn't hold for the moons. For example, we have never been to Triton, the largest moon of Neptune. We've never been to Triton. Triton is a strange and mysterious moon that scientists have never visited. It's a shame because there's so much we could learn from this fascinating world. It is one of the coldest objects in the solar system, with temperatures hovering around -235 degrees Celsius. It's also one of the few moons in the solar system that orbits its planet in a retrograde motion, meaning it travels in the opposite direction to its planet's rotation. So why haven't we been to Triton yet? There are a few reasons. First of all, Triton is really far away from Earth. It's over 4 billion kilometers away, which makes it one of the hardest places in the solar system to reach. Second, Triton is covered in ice, which makes it difficult to land a spacecraft on the surface. Finally, the extreme cold on Triton means that any spacecraft we send there will have to be specially designed to withstand those temperatures. Despite these challenges, scientists are developing mission concepts to send a spacecraft to Triton. One such concept is the Triton Hopper, which would use a lander equipped with a hopping mechanism to explore Triton's surface. Another idea is the Triton mission, which would send a spacecraft to orbit Triton and study its atmosphere, surface, and interior. One of the main reasons why we want to explore Triton is to search for signs of life. While it's unlikely that we'll find living organisms on the frozen moon, there may be evidence of past or present life in the form of organic molecules. There's also the possibility that Triton's subsurface ocean could harbor life, similar to what we found on Jupiter's moon Europa. In addition to its potential for finding life, Triton could provide valuable information about the formation and evolution of the solar system. As a moon that was likely captured by Neptune, Triton may hold clues about the early history of our solar system and how it came to be. Triton remains one of the most intriguing and mysterious places in the solar system. While the challenges of exploring this frozen moon are significant, the potential rewards are enormous. Scientists are working hard to develop mission concepts that will allow us to finally visit Triton and unlock its secrets. Who knows what amazing discoveries we'll make once we finally get there? But hey, let me tell you a secret. Triton is not the only interesting moon in the solar system. In fact, Jupiter's moon Europa has liquid water oceans. This moon has always been a mystery, with its icy surface hiding an unimaginable world beneath. Scientists have been studying this moon since the first hints of liquid water were found during the Voyager mission in 1979, and today they are more confident than ever about the presence of a vast and deep ocean that lies beneath the thick ice shell. Europa's ocean is a true enigma. It is unfathomably deep, wider than the Earth's diameter, and may contain twice as much water as all the oceans on our planet combined. With such an abundance of water, many believe that Europa is the most promising place to look for extraterrestrial life. Recently, scientists have detected thin plumes of water vapor being ejected into space from Europa's surface, which could be a game changer in the search for life. If these plumes are linked to the moon's ocean, a spacecraft could travel through them, sample the water, and analyze it from orbit. Even if Europa's ocean is not ejecting samples, it is possible that the ocean's material could get frozen into the base of the moon's ice shell. As the ice shell flexes from tidal forces, the ocean samples could rise to the surface, allowing a spacecraft to study them remotely. Europa is not the only icy moon in our solar system, but it is a unique world in its own right. While Enceladus, Saturn's moon, also has an ocean spraying into space, it is much smaller than Europa, and its ocean is not as deep. Europa's ocean is vast and mysterious, like staring into the depths of the unknown. Studying Europa's ocean is like peeling an onion. Each layer reveals something new and unexpected. It's a journey of discovery where the ultimate goal is to find the truth about the possibility of life beyond our planet. With technology advancing at a rapid pace, and with the JUICE mission waiting to be launched, we may soon have a chance to unlock the secrets of Europa's ocean and unravel the mysteries of the solar system. Europa might be hiding some secrets, but what about its huge, gaseous planet? Astronomers found out that in the past, Jupiter liked to run towards the Sun and back in a process that's now known as planetary migration. But it wasn't alone. Saturn migrated too. Jupiter and Saturn migrated in the past. These are the two largest planets in our solar system. They both formed farther away from the Sun than their current location. Scientists believe that they migrated inward towards the Sun in a phenomenon called the Grand Track. About 4 billion years ago, Jupiter and Saturn were moving towards each other. Jupiter's gravity pulled on Saturn, causing it to change course and head towards the Sun. As Saturn moved closer to the Sun, it began to feel the effects of the solar wind, which pushed it further towards the inner solar system. As Saturn continued to migrate inward, it pulled on Jupiter's orbit, causing it to move in a similar direction towards the Sun. Once they got close to the Sun's gravity, the planets were trapped in a stable orbit around them. This migration had a big impact on the rest of the solar system. As Jupiter and Saturn moved inward, they scattered and disrupted smaller bodies in the solar system, including asteroids and comets. This made a big impact on the formation and evolution of the rest of the planets, including Earth. Perhaps the most interesting thing is that astronomers currently observe migrating planets in far exoplanetary systems. In these systems, planets can migrate towards or away from their star, depending on their location and the gravitational forces acting on them. The migration can be caused by the gravitational pull of other planets or by interactions with the disk of gas and dust that surrounded the star during the planet's formation. This migration can have a big impact on the planet's atmosphere temperature and overall habitability. Planetary migration could have been one of the key processes that contributed to the development of life as we know it in the solar system. All of these discoveries were made possible by the presence in space of our best telescopes such as Hubble, Spitzer, and now James Webb. These are expensive tools that require years, if not decades, to be conceived, built, and assembled. But in general, just like every other industry, the space industry revolves around money. For example, did you know that a full NASA spacesuit costs around $12 million? A full NASA spacesuit costs $12 million. Amazing, isn't it? If you had to choose between a spacesuit or an expensive house, what would you go for? Let me know in the comments below. If I can be honest, I would go for a house though. Yeah, because I want to settle and maybe have kids. Who knows, maybe one of my children will get the chance to name an exoplanet in the future. Yeah, I'm talking seriously. Something like this already happened. A little kid back in 1930 was told about the discovery of a new planet, the 9th planet of the solar system. Pluto was named by a child. The little kid's name was Venetia Burney, who suggested to her grandfather that the new discovery be named for the Roman god of the underworld, Pluto. He forwarded the name to the Lowell Observatory, and it was selected. Pluto is the only world so far named by an 11-year-old girl. Girls really rock. Light from the sun takes about 8 minutes to get to the Earth. The sun is really far away, something like 93 million miles away. This distance is unimaginably huge, so much that even photons, the fastest particles in the universe, take 8 1/3 minutes to get to us. Not many changes about the sun in such a short time, but it still means that when you look at the sun, you see it as it was 8 minutes ago. You're basically always observing a past version of the sun. This actually applies to every other astrophysical object in the sky, even those lying billions of light years away from us. Perhaps we would never be able to foresee the future, but at least we have access to the past. We may be drinking comets. Have you ever seen a comet? They're big, bright, and kind of rare today. But did you know that comets were much more common in the past? Billions of years ago, when the solar system formed, comets frequently crashed into the Earth. These icy bodies were once so widespread that some scientists believe they may have played a crucial role in forming our planet's water reservoirs. How is that possible? Well, it all comes down to the comets being made up of mostly ice, specifically water ice. When they collided with Earth, the ice melted and formed our vast bodies of water. However, there are other theories about how our oceans were formed, and some questions remain unanswered. The average comet is about 3 miles wide, so it's not surprising that a collision between a comet and Earth can have devastating effects. In fact, scientists speculate that a disastrous comet impact was responsible for the extinction of the dinosaurs. 65 million years ago, a comet measuring around 6 miles in diameter slammed into Earth. The resulting impact released energy equivalent to millions of nuclear bombs, leading to devastating consequences for the planet's inhabitants. Comets are not only fascinating, but they play an essential role in the formation of our universe. They are often referred to as dirty snowballs, a term coined by astronomer Fred Whipple in the 1950s. With their tail trailing behind them, comets are some of the most beautiful objects in our solar system. Although there are other possibilities and some questions remain, the idea that our oceans are really melted comets is probably the best. So go have yourself a glass of comet. But avoid using plastic glasses. We're already full of junk. Even the solar system is full of space debris. Most of it is found around the Earth, and it's our fault. The solar system is full of space debris. Space debris is becoming an increasingly concerning issue in our modern world. With more and more spacecraft and satellites being launched into orbit each year, the amount of debris orbiting the Earth is rapidly increasing. This debris includes everything from spent rocket stages to broken satellites and even loose screws. While it may be easy to dismiss space debris as just another form of pollution, it poses a serious threat to both our planet and future space exploration. One of the biggest dangers of space debris is the possibility of collisions. When an object in space collides with another, it can create a chain reaction of collisions and debris that can cause serious damage to functioning spacecraft and satellites. This can lead to the loss of important scientific data and communication systems, as well as increased risk for astronauts on the International Space Station. To put this into perspective, let's look at the example of the 2009 collision between the Russian military satellite Cosmos 2251 and the American communication satellite Iridium-33. The collision generated over 2,300 fragments, which posed a serious threat to other functioning satellites in the area. While many of these fragments eventually burned up in the Earth's atmosphere, some still remain in orbit today. So what can be done to prevent this buildup of debris and reduce the risk of collisions in the future? One solution is to implement stricter regulations on spacecraft design and disposal. This includes designing spacecraft with a plan for proper disposal once their mission is complete, as well as developing technology to remove existing debris from orbit. Another solution is simply raising awareness among adults and children about the dangers of space debris. By understanding the impact that our space activities have on the environment, we can work to reduce our impact and create a cleaner, safer environment for future space exploration. Space debris is a serious issue that must be addressed in order to ensure the safety of our planet and future space exploration. While it may seem like a distant problem, it is one that affects us all and requires a collaborative effort to find solutions. By working together and raising awareness, we can create a zero-debris environment in the future. The solar system has a zodiacal diffuse light. Zodiacal light is a celestial phenomenon that paints the sky with a faint triangular glow that appears to extend from the sun's direction. This beautiful sight is produced by sunlight reflecting off cosmic dust particles, known as the interplanetary dust cloud. The cloud is composed of tiny particles that are continuously replenished by the infall from comets and collisions among the asteroids. The zodiacal light is like a shy and elusive creature, difficult to spot amidst the brightness of the moon and light pollution. It's like a whisper in a crowded room, barely audible but captivating when heard. To see it, you need to wait for the right moment during twilight, after sunset in spring, and before sunrise in autumn, when the zodiac is at a steep angle to the horizon. The glow is really faint, easily overpowered by the brightness of the moon and light pollution, rendering it invisible. However, when seen in a clear night sky, the zodiacal light is a sight to behold. It literally paints the sky with a faint but mesmerizing glow, and it is a reminder of the vastness of our universe and the beauty that lies within it. Despite its ethereal beauty, the zodiacal light can be a noise source to astronomers. Its proximity to the ecliptic plane, where most planets and asteroids reside, can interfere with observations and make it difficult to spot faint objects in the night sky. In recent years, observations by spacecraft have uncovered significant structures in the zodiacal light, including dust bands associated with debris from particular asteroid families and several cometary trails. This discovery adds to the mystery and beauty of this celestial phenomenon, reminding us that there is always more to explore and discover in the vastness of space. For instance, did you know that the Kuiper Belt has a donut shape? The Kuiper Belt has a donut shape. Now you may be wondering why this region filled with icy objects resembles a donut. Is it because it's Homer Simpson's favorite donut? Well, there could be a possibility, but the real reason is much more scientific. The Kuiper Belt is shaped like a donut due to the gravitational influence of Neptune. As Neptune orbits the Sun, it creates a gravitational field that attracts and repels the objects in the Kuiper Belt. These gravitational forces create gaps or holes in the ring of icy objects, giving it a donut-like shape. However, don't be fooled by its delicious appearance. The Kuiper Belt is home to some of the most interesting objects in our solar system. One of its inhabitants, Pluto, was once considered the 9th planet in our solar system until it was reclassified as a dwarf planet in 2006. Other than Pluto, the Kuiper Belt is filled with other dwarf planets such as Haumea, Makemake, and Eris. Scientists believe that there could be hundreds of thousands of other small icy objects in the Kuiper Belt yet to be discovered. The formation of the Kuiper Belt is still a mystery to scientists. Some theories suggest that it formed in the same way as the rest of the solar system, with icy debris coming together to form larger and larger bodies. Others suggest that it could be remnants from a collision between Neptune and another planet-sized object. Regardless of how it formed, the Kuiper Belt remains a fascinating and mysterious region of our solar system. Who knows what other secrets and discoveries it holds? But for now, let's just appreciate its donut-like appearance and take comfort in the fact that even our solar system has a sweet tooth. Hey, if you're still watching the video, why don't you subscribe to the channel? And if you don't, you're going to end up like Mercury, alone. Mercury, the planet of nothing. It's got nothing going on, no atmosphere to speak of, no rings to show off, no moons to keep it company, and definitely no life. Mercury has no rings, no moons, no atmosphere, and no life. If Mercury was a character in Friends, it would be that weird guy who keeps popping up, but no one really knows anything about him. He's just there doing his own thing, not really contributing much to the plot. And without any life to speak of, Mercury is like the Game of Thrones series finale. It's over and done with, and we can all move on with our lives. But hey, let's not be too harsh on Mercury. Don't forget that it does have some interesting characteristics. It's the closest planet to the Sun, which means it's really hot. And its surface is full of craters and valleys, kind of like that one friend who has a face full of acne scars, but still manages to look cool. So let's raise a glass to Mercury. The planet of nothing may not have much going for it, but at least it's not as annoying as Arturito in La Casa de Papel. And who knows, maybe one day we'll find some little green men living there. But until then, let's just enjoy Mercury for what it is. A planet with nothing, but a whole lot of nothing. Let's talk now about something more interesting. Have you ever noticed how meteoroids, meteors, and meteorites are 3 different words? That's because they are 3 different things. Meteoroids, meteors, and meteorites are 3 different things. Now, I'm sure you're thinking, wow, astronomers really love to complicate things. And you know what? You're absolutely right. They just can't help themselves. But let's break it down a bit. Meteoroids are just space rocks. Think of them as the little siblings of asteroids. They come in all shapes and sizes, from tiny specks of dust to boulder-sized chunks. And when they enter Earth's atmosphere, they heat up and create that beautiful streak of light we call a meteor. Now here's where it gets interesting. If a meteoroid manages to survive the fiery descent through our atmosphere and makes it all the way to the ground, it officially becomes a meteorite. And let me tell you, meteorites are a big deal for astronomers. They give us a glimpse into the mysteries of the universe and can tell us a lot about the history of the solar system. So where's the best place to find meteorites? Well, anywhere there's a lot of open space for them to land. Antarctica is actually a prime spot for meteorite hunters because the icy landscape makes it easier to spot the dark rocks that have fallen from the sky. Plus, with so few people living there, there's less chance of the meteorites getting lost or damaged before they can be collected. So there you have it. Meteoroids, meteors, and meteorites. They may seem complicated, but they're really just different stages in the life of a space rock. And while astronomers may love to make things more complex than they need to be, sometimes it's just because they're so excited about the mysteries of the universe. And who can blame them for that? Anyway, talking about meteors, we have showers of them visible from the Earth. They're an awesome spectacle you don't want to miss. They are best known as shooting stars. Meteor showers happen all over the year. But what exactly are these shooting stars? Well, meteor showers occur when Earth passes through the debris trail left by comets or asteroids. As the particles in the trail collide with our atmosphere, they create a lot of meteors in a short amount of time. This is why meteor showers are often named after the constellation that they appear to be originating from. So how can you spot a meteor shower? Firstly, you'll need to find a dark location away from city lights. Give your eyes some time to adjust to the darkness, and then look up towards the radiant, the point in the sky where the meteors appear to be coming from. You don't need any special equipment, just your eyes. The best time to spot meteor showers is usually between midnight and dawn, and that's when Earth is facing the direction of the debris trail. However, some showers can also be seen in the evening or early morning hours, depending on the specific shower and your location. If you're looking for a particular meteor shower, it's always a good idea to check online to see when it's expected to peak. Keep in mind that the number of meteors you see can vary from year to year, depending on factors like the moon's phase and weather conditions. The quadrantids are visible in December or January, the Lyrids in April, the so-called Perseids in August, the Orionids in October, the Leonids in November, and finally the Geminids in December. So mark your calendars for the next meteor shower and get ready for a magical night. Who knows, you might just make a wish on a shooting star. Now you might ask, is there an estimate of how many meteoroids collide with Earth? The answer is yes. Actually, the Earth is constantly hit by meteoroids, just like the Moon. The Earth is constantly hit by meteoroids, just like the Moon. There are millions of tiny space rocks hurtling towards Earth and the Moon every single hour. These sporadic meteoroids are smaller than 5 centimeters and weigh less than 100 grams, but they enter the Earth's atmosphere at a rate of about 108 per hour. The impact frequency of meteoroids is crucial for understanding the potential dangers that these tiny space rocks pose to our planet and its inhabitants. While most small meteoroids burn up harmlessly in the Earth's atmosphere, larger ones can cause significant damage upon impact. And the Moon is also vulnerable to impacts from meteoroids. In fact, the lunar surface is covered in scars from countless impacts over the course of its history. By studying the impact frequency of meteoroids on the Moon, scientists can gain insights into the evolution of our solar system and the processes that shape the Moon's surface. By studying the impact frequency of meteoroids, we can unlock the secrets of our universe and better understand the potential dangers that lurk in the darkness beyond. Speaking of impacts, have you ever wondered how hard it is for a probe to go through the asteroid belt? Well, here's the answer. It's really easy. This is because the collision probe-asteroid probability is very low, unlike what sci-fi movies suggest. Collision probe-asteroid probability in the asteroid belt is very low. The asteroid belt may contain millions of asteroids, but a space probe navigating through it will still miss them unless it intentionally aims towards one. Even if a probe is flying blindly at speeds comparable to those of an asteroid, it would not hit an asteroid in the main asteroid belt for 10 million years. This rarity can be compared to finding a needle in a haystack. The asteroid belt is like a vast space filled with countless hay bales, but only a few needles. The probability of a probe hitting an asteroid is so low that it is practically impossible. It's like playing a game of darts in a massive stadium with only a few targets. The chances of hitting one are minimal. The idea that a space probe will have to navigate its way through an asteroid field, dodging incoming asteroids left and right, is a myth created by Hollywood to add drama to movies. In reality, the chances of a probe hitting an asteroid in the asteroid belt are incredibly low, and it does not pose a significant threat to space missions. This is a testament to the vastness and emptiness of space, and we should appreciate how rare and unique the asteroid belt truly is. There's only one fact left. Check it out. Saturn would float. Sort of. Saturn would float. Sort of. Yeah, you got it right. Saturn's overall density is only 70% that of water. The outer layers of the planet are actually even less dense than water. So if you could find a giant ocean with a uniform gravitational field, only the outer layers of Saturn would float like a buoyant log. But wait, there's more. As you move towards the center of Saturn, the density increases rapidly, and at about halfway towards the center, it becomes equal to that of water. And at the very center of the planet, the density can be as much as 13 times that of water. So while the outer layers of Saturn would float on water, the inner half of the planet would sink down like a heavy stone. It's kind of like a boat. The outer part of the boat, like the hull, is designed to be buoyant and float on top of the water. But the inside of the boat, like the engine and the anchor, is much denser and would sink straight to the bottom. So while Saturn may seem like a big floating ball, it's actually a bit more complicated than that. But let's be honest, it's still pretty cool to imagine Saturn floating in a giant ocean, right? Maybe we'll find one in the vastness of space someday. Where's the biggest crater in the solar system? The biggest crater in the solar system is on the Moon and is called the Aitken crater. This crater has a diameter of an impressive 2,500 kilometers. That's about half the size of Australia. The Aitken crater is located in the southern part of the Moon and spans the entire South Pole Aitken Basin. This crater is a giant, and its size is difficult to comprehend. To put it in perspective, the giant crater on Earth, Vredefort crater in South Africa, is only 300 kilometers in diameter. Even the famous Beringer crater in Arizona, one of the largest on Earth, is only 1.2 kilometers in diameter. The Aitken crater was formed about 4 billion years ago when a giant asteroid collided with the Moon. The impact was so powerful that it created a vast basin that can be seen even from Earth with powerful telescopes. The Aitken crater is bottomless and has some of the oldest and most primitive terrains in the solar system. Although the Aitken crater is the largest in the solar system, An even more enormous crater may be discovered at some point in the future. Space exploration continues, and we are learning more and more about our solar system. But for now, the Aitken crater remains the king of craters. Mercury's core is huge. Mercury is the smallest of the planets in the solar system, but it has a disproportionately large core compared to its size. Mercury's core is about 85% of the planet's diameter and mainly consists of iron. Mercury's core is so large compared to the planet's size due to its early formation. Scientists believe that Mercury formed about 4.5 billion years ago from the remnants of the nebula that formed the solar system. In the early days of the solar system, the nebula was filled with dust and gas, and collisions between dust and gas grains allowed the accumulation of materials in larger bodies. Mercury suffered a catastrophic collision with a Mars-sized object during the formation process, removing much of the planet's crust. However, Mercury's iron core, which had already begun to form, remained intact and grew. Over time, the core became the main component of the planet. In addition to the planet's early formation, Mercury's close location to the Sun may also have contributed to the size of its core. The intense radiation from the Sun and the high temperature on the planet's surface could have caused the iron in the core to melt, causing it to grow even more significantly. Uranus's rings are almost invisible. Uranus is the seventh planet in the solar system and is characterized as a gas giant with a very dark asteroid ring in its orbit. This ring, known as the Uranus ring, is so dark that it can barely be made out from its surroundings. Scientists believe the ring's dark color is due to dust and ice particles struck by micrometeorites over billions of years. This activity has darkened the surface of the ring, causing it to absorb visible light and reflect very little. In addition, Uranus's ring is made mainly of carbon particles and water ice, which also contributes to its darkness. These particles are believed to be remnants of comets and asteroids that broke up after being deflected by the planet's gravity. Although scientists have studied Uranus's ring for decades, they still don't fully understand why it is so dark. More research and space missions are needed to solve this mystery. Spot of Saturn. Jupiter's Great Red Spot is well known to everyone. But did you know that Saturn also has a substantial spot? This white spot was first discovered by the Voyager spacecraft in 1980 and has been observed by various space missions since then. It is believed to be a big storm similar to Jupiter's Great Red Spot, although much shorter in duration. The white spot is caused by the convection of gases in Saturn's upper atmosphere, creating a giant storm with white clouds. The storm moves around the planet with atmospheric winds lasting from a few months to several years. In 2010, the Cassini spacecraft observed Saturn's white spot, which had formed a few years earlier. Scientists could measure the speed of the winds circling the storm and found they were the strongest ever measured on Saturn, with speeds of up to 550 kilometers per hour. The white spot is just one of many exciting features on Saturn, which continues to be the subject of study and research by scientists and astronomers worldwide. Future space missions will reveal more secrets about this fascinating planet and its environment. Neptune Spot. If we talk about spots, Jupiter and Saturn are not the only ones that have, since Neptune also has its storm that appears from time to time. The dark spot on Neptune was first discovered in 1989 by the Voyager 2 spacecraft. The dark spot is a vast dark vortex in the planet's atmosphere, believed to be a massive storm similar to Jupiter's Great Red Spot. Unlike the Great Red Spot, which has been around for at least 300 years, Neptune's dark spot has a much shorter life cycle. The spot first appeared in 1989, disappeared in 1990, and reappeared in 1994 before fading again in 1995. Since then, it has appeared and disappeared several times. The reason Neptune's dark spot appears and disappears remains a mystery. It is believed that strong winds blowing in the planet's atmosphere may be creating vortices that drag dark materials towards the surface. Other scientists have suggested that the spot could be related to changes in solar activity, which affect the chemical composition of Neptune's atmosphere. Although it is not yet fully understood why Neptune's dark spot appears and disappears, its study has helped scientists better understand the complex dynamics of the giant planets in the solar system. Do Uranus and Neptune rain diamonds? The answer is yes, although probably not in the way you imagine. Uranus and Neptune are known as the ice giants of the solar system, as they are made mostly of ice, rock, and gases like hydrogen, helium, and methane. However, as we go deeper into the atmosphere of these planets, the pressure and temperature increase dramatically. Due to these extreme conditions, the methane decomposes and the carbon molecules are compressed and crystallized, forming small diamond particles. These particles are carried by the violent winds of the planets and are deposited in the deepest layers of the atmosphere. But does it rain diamonds on Uranus and Neptune? Not quite. Due to the extreme pressure and temperature deep in the atmosphere of these planets, diamonds can't fall to the surface. Also, these planets' rain mainly comprises of methane and other gases. However, the formation of diamonds in the atmosphere of Uranus and Neptune remains a fascinating and unique phenomenon in the solar system. Why is the solar corona so hot? The solar corona is the outermost and most visible layer of the Sun's atmosphere. It is a region of ionized gas that extends millions of kilometers in space and can't be seen during a total solar eclipse. A corona is a place of high activity full of magnetic fields, plasma flows, and solar explosions. The corona is surprisingly hot despite being very far from the Sun's surface. It is much hotter than the Sun's surface, the photosphere. While the temperature of the photosphere is around 5,500 degrees Celsius, the corona temperature is several million degrees Celsius. The reason for this high temperature remains a mystery to scientists. One theory is that the magnetic energy stored in the corona is released as heat through non-linear heating processes. Others believe that the energy may come from plasma waves or the energy released during solar flares. Despite its high temperature, the solar corona does not feel hot when viewed from Earth. The corona is highly dim and energy dissipates into space. However, solar activity in the corona can significantly affect Earth, such as interference with satellite communications and power grids. Oort cloud. The Oort cloud is a hypothetical region of the solar system located between 2,000 and 100,000 astronomical units from the Sun, up to a quarter of the distance between our solar system and the nearest star. This cloud is the theoretical home of trillions of icy bodies such as comets and dwarf planets. The Oort cloud is believed to have formed from remnants of the nebula, the cloud of gas and dust that gave rise to the solar system some 4.6 billion years ago. The bodies in this cloud are considered fossils of the solar system's formation process. Despite its enormous size, the Oort cloud is complicated to detect directly because its component objects are so small and distant. However, comets that appear to come from this region have been observed, suggesting that the cloud exists and is the source of many of the long-period comets observed in the solar system. Much of this cloud is still unknown, and it is hoped that future research and space missions can help unravel the Oort's cloud mysteries and the solar system's formation. Least visited planet of all. Despite being discovered in 1781, few space missions have reached the planet Uranus due to its distance and location in the outer solar system. The first and only mission to visit Uranus was the Voyager 2 probe, which flew by the planet in 1986. During that mission, the probe took pictures and collected information about the planet's atmosphere, rings, and moons. Since then, no missions have been dedicated to exploring Uranus in detail. Despite the lack of exploration, astronomers have learned much about Uranus from telescopes on the ground and in space. Uranus is known to be a gas giant planet, similar in size and composition to Neptune. It has an atmosphere made mostly of hydrogen and helium, but also contains small amounts of methane. The presence of methane is believed to give Uranus its distinctive blue-green color. Despite not being fully explored, Uranus remains a fascinating object in the solar system, and there are many unanswered questions about its atmosphere, climate, and rings and moons. Hopefully in the future there will be more missions to explore this enigmatic planet and discover all it has to offer. The only natural satellite with a magnetic field. Ganymede is one of Jupiter's most fascinating satellites, since it is the only one with a magnetic field. This magnetic field is believed to be generated by the interaction of Jupiter's magnetic field with the interior of Ganymede. This interaction can be explained by an underground saltwater ocean below the satellite's surface. The subterranean ocean of Ganymede is in constant motion and is responsible for generating electrical currents. These electrical currents in turn generate a magnetic field that extends around the satellite. This magnetic field is believed to be due to dissolved salts in the water, which conduct electricity and produce a magnetic field. Ganymede is the only satellite in our solar system known to have a significant magnetic field, but it is not the only body in the solar system to have a magnetic field. Most planets and many other bodies, such as the Moon and some asteroids, have magnetic fields to a greater or lesser degree. However, Ganymede's magnetic field is unique due to its origin, resulting from the interaction between the underground ocean and Jupiter's magnetic field.